this is Roger Green, host of the Surfing the NASH Tsunami podcast. This weekend, we are offering 5 conversations from Season 3, Episode 35, our final wrap-up episode looking at basic liver science presentations from the International Liver Congress 2022. Episode 35 reviews 6 basic liver science presentations related to fibrosis that took place at a session of ILC 2022 chaired by Scott Friedman. Scott joins us to lead the discussion on these presentations, while Neil Henderson and Rachel Zayas join the regular service to provide their own perspectives and ask good questions. The first 3 conversations focus on basic liver science presentations and concepts. This one starts with me asking the panelists what the commercial payoffs for these pieces of research and others like them will be. The answers from the panelists vary, but they center around 2 basic kinds of issues. A, that research that deals with more fundamental issues will help drug developers ask smarter, more sophisticated questions. And B, they'll have the ability to target patients better or develop tighter, presumably less expensive trials and or trials with a higher probability of success. Either way, presentations like this are going to be really helpful as the profession continues to develop and as we try to bring more and better tools to market. These conversations cover some challenging and exciting issues in basic liver science. They point towards continued explosive increases in what we understand about NASH and fibrotic process in the liver in general. So sit back, listen, enjoy, learn, and when you're done, join the dialogue on our LinkedIn discussion group.
Scott Friedman.
Although I've chaired many sessions over the years, this was one of the most exciting groups of presentations I've seen in many years. I don't know if it's because the science is just maturing, getting better, and or because there could have been a lot of pent-up, interesting data that just is waiting for presentation. But whatever the reason, I was really jumping out of my seat from all the novelty and the state-of-the-art methods that were used, all of which has a lot of translational potential, none of which is directly addressing treatments because those were the focus of other sessions. So in no particular order, I'm just going to give you an overview. I think some of the conceptual advances included using induced pluripotent stem cells to recreate stellate cells, tracking, and I'm going to go through these in details, of course, tracking the proteomics of different cell types to identify new therapeutic targets, uncovering a circadian clock within hepatic stellate cells, which, to remind you, are the fibrogenic cells in liver, beginning to zero in on the dynamics and the cells regulating matrix degradation in fibrosis regression, and some new insights into how bile ducts get sick and start proliferating when there is injury.
That's great. So do me a favor, about half our audience is fundamentally commercial, either in development or medical affairs or sometimes even in commercialization and marketing. Let's pay this last 15 or 20 minutes off for those folks a little bit in terms of what can they take out of it that will help them understand their worlds or do their jobs better. Can we help them that way, do you think?
Well, maybe I'll start and emphasize that implementation of spectacular new technologies is greatly expanding our appreciation of the underlying biology that will yield therapeutic targets and novel diagnostics. Knowing that there are subtypes of stellate cells that may be more or less fibrogenic leads us to think there may be specific subsets of cells that are worth developing targets for that leave other subtypes unharmed. And there are some real clear examples that I can give you if you'd like. So I would say that is one way of refining, understanding the heterogeneity and the complexity of tissues allows us to much more selectively zero in on the right molecules in the right cell types. And that's very, very important. And presumably will also minimize the off-target effects because the first rule of drug development is don't harm the patient, make sure they're safe. The more focused our targets and the more refined our therapies or diagnostics, the less harm we can inadvertently do to other tissues. I'd also say that the induced pluripotent stem cell technology is beginning to ripen towards really hopeful development of not only novel biology, but actual therapeutic applications and perhaps diagnostic as well. And then I would just say that more or less the summing up, I think all of the presentations in this session really reflect a growing appreciation of the complexity and nuances that we should have expected all along, but will really yield much more clarity about how we go about diagnosing and treating disease.
Jörn Schattenberg.
Following up on Scott's comment, and I endorse his stressing that technology leads to advancement, leads to better understanding. I think the future is about individualization of therapy by employing these techniques, and Neil and Scott are tremendously advancing the field with their basic science approaches here. It will help us to better identify patients or potentially also do more personalized therapy. As of today, if you apply these techniques technologies, it will help us to understand some of the variability we're seeing in these clinical trial populations, because all we do is take a piece of liver, asking the pathologist whether it has fat and inflammation in it and some degree of fibrosis, and then we throw them all in the same pot. Some study sponsors ask for metabolic risk factors, but that's so much just scratching the surface of the pathophysiology of this disease, and these technologies will help us advance this. And if you're able to look at some of that data in your phase 2 programs, in the early programs, the preclinical programs, you're going to think in the end be able to mingle out some of the variation we're seeing that in the end leads to trial failure. So I think these technologies will help us to redefine the target group and the group of the highest unmet need. As such, clearly we need this to move forward and integrate it into the clinical trial development arena.
Yeah, that's a great point, and I would just put a fine point on it by saying what it will hopefully lead to is identifying subgroups of patients with NASH who are more likely to be responsive to a specific therapy. Therefore, the clinical trials can be more focused, they can involve less patients, and they can separate much more clearly responders from non-responders, because it's building on the concept that Jörg articulated that NASH may not be the same disease in every patient. And we can only learn that by going below the surface to define environmental, tissue, genetic, and microbiome, among other things, the factors that make each case of NASH somewhat unique.
It's interesting, Scott, because I think one of the things we've been learning over and over again over the last 3 years slowly is that NASH isn't just one disease, but it's hard to figure out exactly how to characterize the different diseases in ways that make it practical. So what I take out of your comment and yours is that one thing all this does is move us way down the path to being able to do that, to where we not only know that it's different diseases, but we actually know what that means in terms of who to target and what to target them to do, and what that means in terms of drug and diagnostic development. Am I reading you right?
Yeah, and there's an extreme example of that's already in the clinic. It's not extreme, but it's specific, I should say. There was some great work done by Regeneron about 4 years ago, in which they identified a DNA base pair change in a gene none of us ever heard of called HSD17B13. And a particular gene variant of that enzyme protected patients from getting NASH. And what they went on to describe is that when that variant is present, the enzyme is not generated, and so whatever that enzyme is making is no longer there. So one of the smaller companies in the NASH space has already started to use that strategy to replicate the genetic protection using gene therapy, and saying, let's try to use siRNA to knock down the disease-causing variant of HSD17B13. And I have to say, their early data looked very, very promising. So, I think for the cases of NASH where there's clearly a gene variant that is more predisposing to disease, we're reaching the point now where gene therapy is really coming of age and could represent a practical approach to manipulating gene expression in the liver.
Yeah, and let me get really commercial for a minute. For those who think that there's no investment coming into this area, the two companies that were out front on that issue both got acquired within the last year by Big Pharma. So if you actually get to something that makes sense at that level, there are people who will invest a lot of money in chasing your knowledge, which is, I think, an important thing. So Scott, Neil, Scott first, Neil, then everyone else. Anything else from that session you'd like to make sure we cover? We're kind of rolling towards the bottom of the hour. I'd like to start to roll towards conclusion.
Yes, there was one more abstract from a young woman in Heidelberg. Her name was Macrina Lamb. She presented a beautiful comprehensive study looking at the role of a particular receptor known as receptor for advanced glycation end products, or RAGE, as driving a very important response that we see both in NASH and in bile duct diseases, where the bile ducts begin to proliferate and create something called the ductular reaction. And it's been a bit hazy in terms of what is causing the ductular reaction and why does it correlate with fibrosis. There are some candidates, for example, alpha V beta 6 that Neil may know about, but this introduced a new player that might help explain that ductular reaction, at least in animal models. And that's very important for patients in particular, not only who have NASH, but even more so perhaps who have bile duct diseases like PSC and PBC. The work was very convincing, and there are therapeutics being developed against RAGE, so there's a very translational implication of that as well. So I just want to give a shout out to that one additional paper.
Yeah, I personally, of the six, that might be the one I thought was most dazzlingly clear in presentation in terms of I could follow it. I could follow a couple of them better than others. That was one. I thought that what she did was really pretty fantastic. I agree with that. Any other thoughts or comments about that presentation or anything else having to do with fibrosis that we learned or heard in the meeting, maybe outside of that session?
Neil Henderson.
I think, Roger, one other comment I'd make is, we have all these dazzling new technologies and they're giving us incredibly rich information, but what I'm very excited about, and I know many people in the field are, is linkage of this type of data with accurate and rich clinical metadata, that's going to really push the field on as well. And it comes back to Jorn and Scott's points about accurate stratification and placement of patients within subgroups of a given liver disease. As the next few years roll on, there will be very large data sets with linked clinical metadata that I think should really help with all of that accurate stratification, which should help clinical trials in the ways everyone's discussed. The other thing I'd also say is, molecular pathology, AI-driven approaches in molecular pathology, it's incredible the information that the AI approaches are already unearthing from standard H&E histology images. Ally that with potentially these genome-wide molecular readouts, and I know, this is downstream a bit for standard clinical pathology, but it's coming. So the tech driving that type of approach as well, I think, will be incredibly useful, again, for stratifying patients and frankly, learning a lot more about the subtypes of these diseases that we, for a long time, have called one disease. So yeah, exciting times.
That's an interesting comment, Neil. And just to round it up quickly, I think a lot of abstracts I looked at ILC were linking FIB4 categories, most probably the most crude measure you can take of fibrosis, to outcome and survival. And as such, I think we'll see others emerge here, more refined technologies.
Fully agree, Jorn.
Yeah, I agree, Jorn. And then, of course, the challenge is going to be what made FIB4 sexy is that it's cheap and widely accessible. So we're going to have the challenge to figure out how to make other more helpful things do that as well, or to get smart about how to stage our diagnostics. But that's something people are spending a lot of time on already.
And now, back to Roger.
We hope you've enjoyed this recording. If you have any questions or comments about the content of this conversation or the entire episode, please send an email to questions@surfingnash.com. We'll be back next week with a new episode of Surfing the Nash Tsunami on Wednesday, July 13th. I'm pretty sure I know what we're going to talk about, and it's a major news story, but we haven't completely firmed it up yet, so I'll leave you in suspense. Until then, stay safe, surf on. We'll see you on the podcast. Bye-bye now.